Good morning, everybody. My name is Pavel Gnip, and I would like to introduce today the final report of Agrihub Inspire Hackathon 2022. The aim or name of this is analysis, processing, and standardization of data from agriculture machinery for easily utilization by the farmers. Agriculture machinery significantly influence the economic profitability of crop management. How to operate machinery on the field and achieve the best result in the farming business. Data collection from running machine in time, location, and application on the field can be on the basic controlling process for farmer. Collected data could be a base of field database on the farm. From a technical point of view, the monitoring system involves tracking of vehicle position using a GPS combined with acquisition of information from onboard terminal or field sensors, CAN bus and isobus, and their online or offline transfer to GIS environment in the ISO XML format. I would like to also make a full explanation of challenges defining on scope of the effort. First is the visual tracking the machinery fleet, which allows localization on the farm vehicles in real time. This information provides an overview of current operation of machines on the field and is crucial for the planning of the field work and evaluation of the machine usage in the time. The second part is evaluation of economic efficiency of the crop management treatment within the field. A prerequisite is the identification of field and tractor equipment for the accurate estimation of field job cost base on the fuel consumption and usage working time. Evaluation of machinery passes on a soil environment. This includes detailed analysis of the tractor trajectories within the field, considering the site-specific conditions. The aim is to estimate the negative effect of machine tracks on the soil environments, especially soil compaction and compliance of agro-environmental limits, like as a nitrate directive, GAEC, protection of water resource and other protected areas, and open for future update local changes. Methodology, team description, technology-based companies are as a parts, as experts and dealers, network partners as Zemědělský svaz, Agrární komora, and Smart Agrihubs, and business support partners as a test farm. Technical background, it's a web application collected data and upload a via USB disk or GSM network. Data modem on tractors terminals, isobus technology between tractor terminal and implement management box. Methodology, next as a description of the process of solution. Verification of the data collection were done at a medium-sized farm where it was served for evaluation of the tractor's work during operations such as a soil tillage, fertilization, sowing, and application of nutrients and chemicals for crop protection. Similar monitoring of metadata were tested at the enterprise, which is offering service for farmers for assessing the quality of work for customers, and verification of data controlling and visualization was in the first step. Data and equipment list, control of requirements for the field operation, control of pass-to-pass errors and overlaps, coverage and maintaining areas, recommended work speed, control of applied input materials of comparisons to prescribed rates, on a line monitor of weeds, on a line monitor of weather. What we are looking for is to collect mainly three groups of data: agronomic data from tractor and implement, So in the agronomic data altogether, we need the data from tractor and implement as a boom setting point application rate, actual application rate, total volume and total areas. As a tractor data, we are collecting in the board computer as a total area per time, active road, inactive road, which means the road or the time on road out of the field, active working time, inactive working time, same as a road, and total fuel consumption, actual fuel consumption in working time. What we are collecting from the implement separately is a boom, active road, inactive road, active working and inactive working time. Finding and conclusion. Practical machines field report is automatic data collection monitoring a fieldwork task. This data can help a farmer to summarize cost on the field separately from the farm overhead cost. Farmer has on the hand a precise cost and approve it and proves when, where and how was application done and what product was applied. In the left picture, we can see how we monitor the data from the field and how we collect it. Then we can see the map from the field. And on the right side, we can have a look, a simple report where the farmer can see immediately the numbers we have mentioned we are collecting from the machine and implement together. Further improvements. Verification, data controlling and visualization was the first step, as I mentioned before. Next step will analyze data with a focus on evaluation of economic efficiency of machinery operation within the fields and farms, which means so data we mentioned and show as an example we collected on the previous slide. We would like to also collect these data from the complete operations from one field, from one season, and just follow the next seasons. And then just make a same collection of data from each field on the farm. Depend on the crop, which is planted, or depend on the season. Precise records, another is a precise record of the crop management treatment. So it means just to follow crop planning step by step as is recommended. Management of machinery operation, increasing of efficiency of planning of crop management. It means is we get the data and get an overview, a very precise overview how the work is going on the field, on how we collected the data from the machine. We can decide it, actually the farmer can decide it immediately how to work and how to plan the next work on the field or next other fields on the farm. Control of requirements for the field operations. It means when we find some mistakes on the work as a positioning mistake or as other mistakes of data collection or so on, we can still make fix the bugs or fix the mistakes on the system, on the database. Control of pass errors and overlaps, coverage of maintenance area and recommended work speed. This is exactly what the farmer is looking for, and when the farmer can save the most cost of the whole work. Control of applied input materials in a comparison to VRC maps. It's also one very important follow steps which the farmer should come to. Thank you for being a part of the Agrihub Inspire and Hackathon 2022.